Good day. In this video, we are going to do the last question or 3C of the 2022 NCEA Level 2 Apply Calculus method in solving equation. Without further ado, let's read the question. So, a calculus class is exploring a three-dimensional geographical art. The students decide that they want to create a wireframe models of the tetrahedron and the octahedron, similar to those shown below. So the surface area for the tetrahedron is square root of 3a squared, and the surface area of the octahedron is 2 square root 3b squared, where b represents the length of the tetrahedron, when a represents the edge of the tetrahedron. So they will make each edge with a piece of wire and join the piece together, and then cover each surface area with paper to create lanterns similar to those below. They wish to create each model so that the total resulting surface area of the two shapes is the minimum. They have a total of 180 cm of wire to cut and use for both models. Determine the length of edges A and B required to minimize the total surface area of the two shapes when all of the wire is used. Use calculus to justify that the surface area is the minimum. So we know that the length of each tetrahedron is A, so all of them are A. So they are all together 6A in a tetrahedron, so that will be 6A. And the octahedron, they are B, so they are all together, I'm not writing everything, so they are all together 12 B's in a octahedron. Okay, so now we need to make an equation based on the octahedron and tetrahedron. So surface area, I'm going to write here because I got no space, is equal to this formula, square root of 3a squared plus 2 square root of 3b squared. So once we know this, we need to form an equation. So there are 6 a's in a tetrahedron, so 6a plus 12b's, that will be equal to not more than 80 centimeter. Okay, so now we're going to simplify. We can make A the subject of formula, or B, we decide to do A because the marking schedule say is A, so we're going to follow the marking schedule. So we're going to minus 12B on both sides. So 180 minus 12B. So A is going to be you divide by 6 next, okay? And then it's going to be 30 minus 2B. Okay, so now we know that formula, the A is 30 minus 2B. We can substitute that formula into A formula. So surface area is going to be square root of 30 minus 2b squared plus 2 square root 3b squared. Okay, now what we're going to do, we're going to expand this expression. So it's going to be root 3, 30 squared is going to be 900 plus 4b squared. 2b squared is going to be 4b squared, and then you minus 2ab, so 2 times 30 times 2 is going to be 120b. Yep, that's right, plus this number here, 2 square root 3b squared. Okay, now we are going to simplify the expression. So now we're going to expand this. It's going to be, I'm going to make it light here, okay? So it's going to be 900 root 3. Let me check. Yep, it's going to be expanded. Going to be 900 root 3 plus 4 root 3b squared minus 120 root 3b plus 2 root 3b squared. They are like terms here. So we're going to be simplified by 6. 2, 4, and 4 is going to be 6 root 3b squared plus 900 root 3 minus 120 root 3b. Okay, so now we are closer to the solution. So to get the maximum value, we need to differentiate. So SA1 is going to be, bring the 2 down, become 12 root 3b. This become nothing, and that become minus 120 root 3. Okay, so now we need to solve for B and A to solve the equation. For maximum and minimum value, the first derivative of S surface area 1 is equal to 0. So we're going to solve that. 0 equals to 12 root 3b minus 120 root 3. Okay. So now we are going to either one, we're going to plus 120 root 3 on both sides. So you're going to be 120 root 3 is equal to 12 root 3b because this will cancel out. So last step, we're going to divide both sides by 12 root 3, and that will cancel out, and you get b is equal to 10. Once you found b equal to 10, we are going to substitute b equal to 10 into the first equation that we found here. Okay, so we're going to substitute that. So a is equal to 30 minus 2, 10. So a is also equal to 10. So a is 10 and b is also 10. Excuse me. So to justify the last part, to justify that is a minimum area, we need to do the second derivative. So SA, the second derivative of that, the first derivative was here. When you differentiate one more time, the answer is going to be 12 root 3. So this is always positive, and that's why it's always a minimum value. When the second derivative is a positive number, when you substitute them, it's a minimum. If it's a negative, it's a maximum. So in this case, no matter what, the second derivative is going to be 12 root 3. It's a positive number, so it is a minimum value. So if you can confirm that this is the minimum, and you can find A and B in this question, you will get an excellence in this question and an E7 in your exam. So if you don't understand, please have a go again. A lot of calculation involved, but if you understand this, it's all good. Cheers everyone, and I'll see you in the next video, which in fact it's all completed now. You should go through the whole paper from 1A to 3C, and if you can ace them, well done. Cheers everyone, and see you soon.